5 in the morning, 1943. The sky over South Bethlehem glows orange from the open hearth furnaces working through the night. The air carries the weight of sulfur and molten iron. Inside the plant, men move through corridors of heat so intense that new workers faint within minutes. The blast furnaces roar at 2,000 degrees. The rolling mills scream as red-hot steel beams emerge like ribbons of fire. This is not a factory. This is the engine room of American power. 68,000 tons of Bethlehem steel will cross the country to become the Golden Gate Bridge. Another 1,000,000 tons will become the skeleton of Manhattan. The company that built America's skyline, forged its warships, and armed 2 world wars would one day file for bankruptcy, abandon 95,000 pensions, and leave behind nothing but rusting monuments to an empire that vanished. Was this the inevitable price of global capitalism? Or did the men in the executive suites simply stop believing in their own future? The origins of American industrial power are written in iron and blood. Before there was steel, there was iron. And before there was iron, there was ambition channeled through the geography of eastern Pennsylvania. The Lehigh Valley offered everything an aspiring ironmaster could want: proximity to anthracite coal deposits, water power from the Lehigh River, and access to expanding railroad networks that could carry finished products to markets across the growing nation. In April 1857, a man named Augustus Wohler recognized these advantages and organized the Socona Iron Company in the small town of Bethlehem. His timing could not have been worse. Within months, the Panic of 1857 swept across America like a financial plague, collapsing banks from New York to San Francisco, halting construction projects, and freezing credit markets. The fledgling company stalled before it ever produced a single rail. But geography does not change with financial panics. Bethlehem still sat at the junction of the North Pennsylvania and Lehigh Valley railroads, positioned where water power and transportation access converged in a configuration that seemed designed for industrial enterprise. The iron deposits of eastern Pennsylvania remained within reach. The expanding railroad networks of the Northeast still needed rails faster than they could import them from Britain. When the economy recovered in 1859, the company reorganized, relocated to South Bethlehem, and renamed itself the Bethlehem Rolling Mill and Iron Company. On June 14, 1860, the board of directors elected Alfred Hunt as president. Within a year, the nation would be at war. The Civil War transformed the iron industry, just as it transformed everything else in American life. The Union Army needed rails to move troops and supplies across a continental theater of operations. The Navy needed armor plating for a new generation of ironclad warships that would revolutionize naval warfare. The demands of total war accelerated industrial development that might otherwise have taken decades. Construction of Bethlehem's first blast furnace began on July 1, 1861, just months after Confederate batteries opened fire on Fort Sumter. The furnace became operational on January 4, 1863, the same month that Lincoln issued the Emancipation Proclamation. The first railroad rails rolled off the production line on September 26th of that year. A machine shop followed in 1865, a second blast furnace in 1867. The company, now renamed the Bethlehem Iron Company, was finding its footing, learning the industrial processes that would eventually make it essential to American power. During these formative years, production focused on rails for the rapidly expanding railroad networks and armor plating for the United States Navy. The company was building a reputation for quality at a moment when the federal government was willing to pay premium prices for reliable suppliers. The workers who manned these early operations came from diverse backgrounds: skilled iron workers from Wales and England who brought knowledge of European techniques, German immigrants with experience in metallurgy, and native-born Americans seeking wages that exceeded what farming could provide. They worked 12-hour shifts in conditions that would be considered intolerable by later standards, but the wages were steady and the work was available. A community began to form around the plant, with boarding houses, saloons, and churches sprouting along the streets of South Bethlehem to serve the growing workforce. The metallurgical revolution arrived in 1856, when English inventor Henry Bessemer patented a process for converting molten pig iron into steel by blowing air through the liquid metal to remove carbon and other impurities. The chemistry was elegant, Oxygen in the air combined with carbon in the iron, releasing it as carbon dioxide and leaving behind a metal that was stronger, more durable, and more versatile than wrought iron. Steel could support taller buildings, longer bridges, and heavier locomotives. It could hold a sharper edge on cutting tools and withstand greater stress in machine components. The implications for industrial civilization were profound, though few could yet imagine the full extent of what steel would make possible. In 1873, Bethlehem became the first American company to incorporate Bessemer technology into its manufacturing operations. The transition from iron to steel opened markets that iron production alone could never have captured. Steel rails lasted longer than iron rails, reducing replacement costs for railroads willing to pay the higher initial price. Steel beams could span greater distances and support heavier loads, enabling architectural and engineering projects that iron construction simply could not accommodate. But rails alone could not sustain Bethlehem against the relentless cost-cutting of Andrew Carnegie's Pittsburgh empire. Carnegie Steel dominated the rail market through ruthless vertical integration, owning everything from iron ore mines in the Lake Superior region to the shipping lines that transported ore to Pittsburgh to the mills that transformed it into finished products. Carnegie's obsession with cost reduction drove prices down year after year, squeezing margins for competitors who lacked his scale and integration. Bethlehem could not compete on price in the commodity rail market. It needed to find a niche where quality commanded premium prices and where the United States government would serve as the anchor customer. That opportunity arrived in 1885 when Bethlehem secured a contract with the Navy to produce armor plating for a new generation of steel warships. The American fleet was modernizing, transitioning from wooden sailing ships to steam-powered steel-hulled vessels capable of projecting power across oceans. Armor plate for warships demanded steel of exceptional quality, processed to specific hardness requirements, and tested to withstand artillery bombardment. The Navy was willing to pay premium prices for suppliers who could meet its demanding specifications. Between 1888 and 1892, the company constructed America's first heavy forging plant, designed by the legendary ironmaster John Fritz with assistance from Russell Wheeler Davenport. By autumn 1890, Bethlehem Iron was delivering gun forgings to the military and completing the facilities needed to supply armor plating. The Spanish-American War of 1898 validated this strategy. Bethlehem supplied armor plate, guns, and other military hardware that contributed to American victories in Cuba and the Philippines. The company emerged from the conflict with an enhanced reputation and expanded relationships with military procurement officials. More importantly, the war established a pattern that would persist for decades. Bethlehem Steel would prosper when America mobilized for conflict, and its fortunes would be tied to the expansion of American military power. The company displayed its capabilities at the 1893 Chicago World's Fair, supplying enough iron and steel to construct the world's first Ferris wheel, which stood 264 feet tall and carried more than 2,000 passengers at a time. This was manufacturing on a scale that impressed visitors from around the world, a demonstration that American industry could match or exceed anything produced in Europe. But Bethlehem remained a regional enterprise, important but not essential to the American economy. Employment reached a few thousand workers. Production facilities sprawled across a campus that was expanding but not yet enormous by the standards of Pittsburgh's massive integrated mills. The real transformation into a true industrial colossus would require a different kind of leadership. Charles Michael Schwab was born on February 18, 1862, in Williamsburg, Pennsylvania, the son of a woolen worker and blanket manufacturer. He received a modest education at St. Francis College in Loretto, but left after 2 years to seek his fortune in Pittsburgh. In 1879, at 17 years old, he took a job as a $1-a-day laborer at the Edgar Thomson Steel Works, a Carnegie-owned facility in Braddock that was then the most advanced steel mill in America. His rise through the ranks was meteoric. Carnegie recognized talent and rewarded it with responsibility. Within 2 years, Schwab was supervising operations. By 19, he was managing the entire plant. The older workers who had spent decades learning their trade watched this young man leap over them with a mixture of resentment and grudging respect. Schwab worked alongside them, learned their methods, and never pretended to know more than he did about the technical aspects of steelmaking. What he understood instinctively was how to lead. Schwab's genius lay not in engineering or finance, but in human relations. He possessed an almost supernatural ability to motivate workers, charm investors, and navigate the treacherous politics of corporate boardrooms. He remembered names, asked about families, celebrated accomplishments, and made people feel valued. Workers who might have resented a young manager lording authority over them instead worked harder to please Charlie Schwab. He walked through the mills regularly, greeting workers by name, inquiring about sick children and aging parents, congratulating men whose sons had been born or whose daughters had married. His personality was perfectly suited to the paternalistic capitalism of the late 19th century, when corporations expected loyalty from workers and rewarded it with job security rather than with the contractual protections of union representation. Carnegie recognized these gifts and promoted Schwab through increasingly important positions. By 1897, at 35 years old, Charles Schwab had become president of the Carnegie Steel Company, the largest steel producer in America and the engine of Andrew Carnegie's vast fortune. In 1900, Schwab delivered a speech at a dinner in New York that outlined his vision for consolidating the fragmented steel industry into a single corporation. The speech impressed J.P. Morgan, the most powerful banker in America, who had been contemplating how to bring order to an industry perpetually prone to ruinous competition. Morgan asked Schwab to broker negotiations with Andrew Carnegie, the one man whose cooperation was essential to any consolidation plan. The negotiations that followed were conducted in secret, with Schwab serving as intermediary between Morgan and Carnegie. Carnegie set his price at $480 million, an astronomical sum that would have seemed impossible just a few years earlier. Morgan agreed without hesitation. On February 25, 1901, the United States Steel Corporation was announced to the world, the first billion-dollar company in human history. It combined Carnegie Steel with Federal Steel, National Steel, and several other producers to create an entity that controlled roughly 65% of American steel production. Schwab, who had made the merger possible, became its first president. The young man from Williamsburg had risen from dollar-a-day laborer to head of the largest industrial corporation ever created in less than 25 years. The partnership between Schwab and the Morgan interests was troubled from the start. Schwab's flamboyant lifestyle clashed with Morgan's conservative sensibilities. In January 1902, newspapers reported that Schwab had been gambling at Monte Carlo, a scandal that embarrassed the button-down bankers on his board. The reports described him wagering enormous sums at the roulette tables, while American newspapers ran headlines about the president of the world's largest corporation throwing money away in European casinos. Morgan was furious. Elbert Gary, the austere lawyer who served as chairman of U.S. Steel's executive committee, used the episode to undermine Schwab's authority. The tensions festered throughout 1902, with Schwab increasingly isolated within the organization he had helped create. Then came the collapse of the United States Shipbuilding Company, a venture in which Schwab had invested heavily. The company was supposed to consolidate American shipyards into a single powerful enterprise, with Bethlehem Steel providing the anchor. Instead, the merger fell apart amid accusations of fraud and mismanagement. A receiver accused Schwab of causing the company's failure and cheating investors. Schwab denied the charges, but the damage to his reputation was severe. Andrew Carnegie, his former mentor, publicly repudiated him. By the summer of 1903, Schwab's position at U.S. Steel had become untenable. He resigned in August, citing health problems that were all too real. The stress had left him with insomnia, numbness in his limbs, and episodes of fainting. The man who had orchestrated the creation of American industry's greatest corporation found himself, at 39, cast out of the company he had built. The man who had been the highest-paid executive in America found himself at 39 years old with a damaged reputation, failing health, and assets tied up in a small steel company that seemed destined for mediocrity. That company was Bethlehem Steel, which Schwab had acquired as a personal investment during his time at U.S. Steel. The demotion from running a billion-dollar corporation to leading a company worth less than $9 million might have embarrassed a lesser man. Schwab saw it as an opportunity to build something entirely his own. Schwab arrived in Bethlehem in 1904 with a vision that seemed audacious to the point of recklessness. He announced publicly that he intended to make Bethlehem the greatest armor plate and gun factory in the world. On December 10, 1904, he incorporated the Bethlehem Steel Corporation, consolidating the original company with shipyards in San Francisco, Delaware, and New Jersey that had survived the U.S. shipbuilding collapse. "I backed the company with every dollar I could borrow," he later described. He acquired new branch plants and closed unprofitable ones. He bought large tracts of land east of South Bethlehem for future expansion. He mechanized the company's iron ore operations in Cuba. The veteran Bethlehem executives chafed under the new regime. The Packer Group, descendants of the railroad magnate Asa Packer, who had long controlled the company, resisted changes that threatened their authority. Schwab ousted them systematically, replacing established managers with men who shared his vision. The gamble that would define Bethlehem's future centered on a technology that the rest of the American steel industry had rejected. Henry Gray, an English steelman who had worked in various American mills during the late 19th century, had developed a new process for rolling wide-flange structural beams. Traditional I-beams, the structural members that supported buildings and bridges, had narrow flanges that limited their load-bearing capacity. Gray's process used horizontal and vertical rollers to produce beams with flanges as wide as 16.5 inches, dramatically increasing their strength while reducing their weight. The geometry of the H-shaped cross-section made the beams more resistant to bending under load. These wide flange beams could support taller buildings and longer bridges than anything previously possible. But the technology required massive capital investment. A new rolling mill had to be built from scratch, with equipment that did not exist in any American facility. The market for the new product was uncertain. Architects and engineers, conservative by training and liability conscious by necessity, might refuse to specify an unproven material. No American steel company was willing to take the risk. Andrew Carnegie, whose judgment on steel industry matters carried enormous weight, dismissed the idea. "Pioneering don't pay," he declared, a maxim that captured the risk aversion of an industry more comfortable with incremental improvements than revolutionary changes. Architects publicly worried that buildings constructed with Gray's beams would be top-heavy and collapse in high winds. The concern seemed reasonable given the lack of performance data on the new structural members. When a German firm built a small Gray mill in Luxembourg in 1902, the American industry watched with interest but declined to follow. Schwab traveled to Europe, inspected Gray's operation, and came home convinced that wide-flange beams would revolutionize construction. The strength-to-weight ratio was superior to anything available. The cost per unit of load-bearing capacity was lower. The production process was elegant, using a single rolling operation rather than the multiple passes required for fabricated sections. If Schwab could establish Bethlehem as the sole American producer of wide-flange beams, he could capture a market that did not yet exist, but that he believed would grow enormously as architects discovered what the new material could accomplish. In 1905, he purchased the U.S. rights to Gray's patents. Now he needed to build a mill capable of producing the beams in commercial quantities. Then, in October 1907, the Panic of 1907 struck with devastating force. A failed attempt to corner the market in United Copper Company stock triggered a cascade of bank runs that threatened to collapse the entire American financial system. J.P. Morgan personally organized a bailout of the banking sector, but credit markets froze for months. New bond issues became impossible. The capital Schwab needed to build the Gray mill simply was not available through normal channels. Schwab retreated to a New York hotel with his secretary James Wardy Ward to consider his options. The bookkeepers at Bethlehem argued that the company could not afford the risk. Building the Gray mill would require borrowing at precisely the moment when banks were refusing to lend. The project might bankrupt the company. It might destroy everything Schwab had built since leaving U.S. Steel. According to Eugene Grace, Schwab spent a day and a night considering the decision, pacing his hotel room, reviewing the numbers, weighing the risks against the potential rewards. Early the next morning, the phone rang in Ward's room. "Get up, Wardy," Schwab said. "We are going back to Bethlehem and talk to the boys. I've thought the whole thing over, and if we are going bust, we will go bust big." Schwab scraped together capital from every available source. Wealthy friends invested on the strength of his reputation. Contractors who believed in the project advanced funds against future payments. Investment banker Pliny Fisk, who had helped Schwab through previous difficulties, worked to find financing despite the frozen credit markets. The gray mill rose along the Lehigh River, costing 3 times the original estimates as difficulties multiplied but never stopping construction. Workers labored through winter cold and summer heat, erecting the massive structure that would house equipment unlike anything American industry had ever seen. The mill went into production in January 1908. Now Schwab needed customers. One potential customer after another declined to take a chance on the unproven product. Architects cited concerns about structural integrity. Engineers demanded performance data that did not yet exist. Salvation came through an unlikely chain of connections. Pliny Fisk had been commissioned by Gimbel Brothers to sell bonds for their new flagship store in New York. As a condition for continuing his work, Fisk demanded that the structural steel come from Bethlehem. The contractor and architect agreed. They had little choice. The Gimbel Brothers store opened to acclaim. The wide flange beams performed exactly as Schwab had promised. Within months, orders were flooding into Bethlehem. By August 1909, the Gray Mill's products had become the company's biggest moneymakers. Into the late 1920s, Bethlehem maintained exclusive control of wide flange beam production. U.S. Steel did not begin rolling competitive Carnegie beams until 1927, nearly 2 decades after Bethlehem had established its dominance. The impact on American cities was transformative. The Woolworth Building rose 57 stories above Lower Manhattan in 1913, becoming the tallest building in the world. Its steel skeleton, fabricated from Bethlehem beams, supported a Gothic revival tower that seemed to defy the limitations of traditional construction. Architects discovered that the new material allowed them to design buildings that would have been impossible with fabricated sections. The catalog of structures built with Bethlehem steel during the following decades reads like an inventory of American ambition. The Empire State Building rising 102 stories above Midtown Manhattan, Rockefeller Center transforming Midtown into the business capital of the world, the Chrysler Building with its Art Deco spire, the Waldorf Astoria, Madison Square Garden, the Cathedral of Learning at the University of Pittsburgh, the Supreme Court Building. Carson Diffenderfer, Bethlehem's chief engineer, captured the company's dominance. Bethlehem Steel owned New York. By some estimates, the company provided steel for 80% of the Manhattan skyline. Schwab recognized that he could not manage the company's growth alone. He needed lieutenants who shared his vision and could execute his plans with autonomy. His most important subordinate was Eugene Gifford Grace. Born on August 27, 1876, in Cape May, New Jersey, the son of a sea captain, Grace attended Lehigh University in Bethlehem, played shortstop with a batting average reported at .400, and graduated as valedictorian in 1899. The Boston Braves offered him a professional contract. He turned it down to work as a crane operator at Bethlehem Steel. His management abilities quickly became apparent. Schwab promoted him through increasingly responsible positions, recognizing in Grace the same combination of technical competence and leadership capability that had defined Schwab's own rise through Carnegie Steel. Together, Schwab and Grace became the team that built Bethlehem from a small producer with an ingot capacity of less than 1% of the national total in 1905 to the world's second-largest steel producer in fewer than 35 years. Their partnership combined Schwab's entrepreneurial vision with Grace's operational discipline. Schwab focused on strategy, acquisitions, and external relationships. Grace managed day-to-day operations, drove efficiency improvements, and built the organizational structures needed to coordinate an increasingly complex enterprise. Grace became president in 1916, with Schwab remaining as chairman. The division of responsibility suited both men's temperaments. Schwab could pursue the grand projects and high-level negotiations that energized him, while Grace ensured that the mills ran efficiently and the books balanced. The arrangement would persist until Schwab's death in 1939. The compensation structure that Schwab and Grace instituted reflected the aggressive growth orientation of their leadership. Grace received bonuses tied to company performance that reached extraordinary levels. In 1929, his bonus exceeded $1.6 million, roughly 3% of the company's total earnings. This was wealth on a scale that ordinary workers could barely comprehend. The transformation of Bethlehem from a provincial steel company into a national industrial power required more than bold leadership and technological innovation. It required systematic expansion through acquisition, vertical integration of supply chains, and the development of managerial capabilities that could coordinate increasingly complex operations. Schwab understood that growth required control of raw materials, control of transportation, control of skilled labor, and control of the markets where finished products competed. In the years following the Gray Mill's success, Bethlehem acquired interests in iron ore mines in Cuba, where deposits of exceptional quality could be extracted more cheaply than from domestic sources. The company invested in coal properties that supplied the coke needed to fuel blast furnaces. Transportation links to ports and railroad terminals ensured reliable movement of materials from mines to mills to customers. The geographic expansion mirrored the growth of the American economy itself. The Union Iron Works in San Francisco, the Four River Shipyard in Massachusetts, facilities in Delaware and New Jersey, each represented strategic positioning for markets that the company intended to dominate. The workforce that operated these far-flung facilities required management systems that could maintain quality and coordination across thousands of miles. Schwab drew on practices he had developed at Carnegie Steel, where centralized financial controls combined with decentralized operational authority to balance efficiency with responsiveness. The outbreak of World War I in August 1914 transformed Bethlehem Steel from a successful American company into an arsenal of global significance. Before the United States entered the conflict, the Allied powers desperately needed weapons, ammunition, and military equipment that their own industries could not supply in sufficient quantities. The factories of Britain and France were already operating at capacity, and the demands of modern warfare, the machine guns, the artillery shells, the barbed wire, the steel helmets, exceeded anything that 19th-century military planners had imagined. American neutrality laws prohibited direct government-to-government arms sales, but private companies faced fewer restrictions. Bethlehem Steel moved aggressively to capture the Allied orders. In 1915, Britain awarded the company a contract worth $135 million, the largest single order in Bethlehem's history. French orders followed. The company's shipyards, acquired through the complicated U.S. shipbuilding transaction that had nearly destroyed Schwab's career, now produced vessels for Allied navies. The munitions facilities at the Bethlehem plant worked around the clock to fill orders for artillery shells and other ordnance. Workers who had never seen a weapon learned to manufacture implements of destruction with the same precision they had brought to structural beams. Schwab personally orchestrated much of this business, traveling repeatedly to Europe to negotiate with government officials, despite the risks of transatlantic passage during submarine warfare. When German U-boats threatened to sink any ship crossing the Atlantic, Schwab made the voyage anyway, his vessel proceeding under armed escort. One ship ahead of his was torpedoed. Schwab's vessel helped rescue 900 survivors from the frigid waters. The experience only reinforced his determination to support the Allied cause. In England, Schwab met with officials of the British Admiralty, including Winston Churchill, who conveyed the desperate need for submarines to counter the German threat. German U-boats were sinking Allied shipping at a rate that threatened to starve Britain into submission. The Admiralty asked whether Bethlehem could deliver 20 submarines as quickly as possible. Submarines normally required more than a year to construct. Schwab promised delivery within 6 months. He communicated with his managers in coded messages to avoid interception and organized a crash production program that delivered on schedule. The submarines were shipped in pieces to Canada, assembled there to avoid violating American neutrality, and deployed against the German Navy. Before the war, Bethlehem's annual profits had averaged around $2 million. During the war years, profits reached as high as $40 million annually. The company's stock price quintupled. By the late teens, lists of the largest industrial companies ranked Bethlehem third, behind only U.S. Steel and Standard Oil of New Jersey. Whatever damage the Monte Carlo scandal and the shipbuilding collapse had done to Schwab's reputation was undone by his wartime contributions. He emerged from the conflict as an international hero, the industrialist whose genius had armed the Allies and helped save democracy from German militarism. The wartime expansion fundamentally altered the scale and complexity of Bethlehem's operations. The company that had entered the war as a significant but regional producer emerged as a global enterprise with facilities, supply chains, and customer relationships spanning multiple continents. When the United States entered the war in April 1917, President Woodrow Wilson personally asked Schwab to become Director General of the Emergency Fleet Corporation. Schwab replaced the existing cost-plus contracting system, which rewarded contractors for spending more rather than less, with fixed-price contracts that rewarded efficiency. Shipyards that could build vessels under budget kept the savings. The 1920s brought continued expansion. Bethlehem acquired the Lackawanna Steel Company in 1922, bringing a major plant near Buffalo and significant coal holdings. Midvale Steel and Cambria Steel followed, making Bethlehem a truly national enterprise. The skyscraper boom transformed American cities, and Bethlehem beams formed the skeletons of the towers rising across the land. The George Washington Bridge across the Hudson River required vast quantities of structural steel, the Benjamin Franklin Bridge in Philadelphia. And in San Francisco, the most ambitious bridge project yet attempted, the Golden Gate. The span would cross 4,200 feet of open water at the entrance to San Francisco Bay, connecting the city to Marin County across a strait known for powerful currents, persistent fog, and seismic instability. The two main towers would rise 746 feet above the water, taller than any bridge towers ever constructed. The forces involved were enormous, the conditions unforgiving, the margin for error essentially zero. Engineers had calculated that the bridge would need to withstand winds of over 100 miles per hour, earthquake tremors, and the relentless corrosive assault of salt water and fog. Many experts believed the project was impossible. Construction began on January 5, 1933, in the depths of the Great Depression, employing thousands of workers at a time when unemployment approached 25% nationally. The men who built the Golden Gate came from across America, drawn by the promise of steady wages in an economy that offered few alternatives. They worked hundreds of feet above the churning waters of the strait, knowing that a fall meant almost certain death. 11 men would die during the construction, though the use of safety nets, an innovation for the time, saved many others who would otherwise have perished. The McClintock Marshall Construction Company, a subsidiary of Bethlehem Steel, served as the primary contractor. The steel came from 5 different Bethlehem plants, including the original facility in Pennsylvania that had started as a modest ironworks before the Civil War. It was loaded onto rail cars, transported across the continent to Philadelphia, shipped through the Panama Canal, and delivered to San Francisco for fabrication and erection. The logistics of moving tens of thousands of tons of steel across a continent and through an ocean required coordination on a scale that matched the engineering challenges of the bridge itself. Each tower contained 44,000 metric tons of steel plates, held together with 600,000 rivets. The rivets were heated on-site in portable coal-burning forges that looked like barbecues, then tossed to the riveters, who caught them in cones, grabbed them with tongs, and installed them before they cooled. A rivet that cooled before installation was useless and had to be discarded. The riveters worked with a rhythm that became almost musical, the clink of metal on metal echoing across the strait as each rivet was driven home. The construction process combined industrial-scale fabrication with hand craftsmanship on a scale that seems almost impossible to contemporary sensibilities. The bridge opened on May 27, 1937, ahead of schedule and under budget. 200,000 people walked across it on opening day. Charles Schwab died in September 1939, just weeks after Germany invaded Poland. His fortune had largely evaporated during the Depression, and he left behind debts rather than wealth. But the company he had built was about to demonstrate once again its importance to American power. Eugene Grace now assumed complete control. According to accounts that circulated within the company, Grace received word of the German invasion while on the golf course at Saucon Valley Country Club. "Gentlemen," he reportedly told his playing partners, "we are going to make a lot of money." He was right. Grace immediately began preparing the company for wartime production, expanding capacity, hiring workers, and negotiating contracts with military procurement officials who remembered Bethlehem's contributions to the previous war. Bethlehem Steel emerged from World War II as the nation's largest defense contractor, having produced 73.4 million tons of steel between 1940 and 1945, almost one-third of the armor plate and gun forgings used by the United States. This total represented a mobilization of industrial capacity that had no precedent in human history. Grace geared the company's entire capacity toward military production, pushing output beyond theoretical limits that engineers had considered inviolable. Between 1941 and 1944, Bethlehem operated at 101% of rated capacity through round-the-clock operations, elimination of maintenance delays, and relentless pressure to maximize output regardless of cost. The company's 15 shipyards produced 1,021 ships during the war, more than any other builder in America. In 1943 alone, Bethlehem built 380 vessels. Grace had promised President Roosevelt that the company would produce one ship per day. He exceeded that commitment by 15 ships. Employment expanded to approximately 300,000 workers, with 180,000 in shipbuilding. The Bethlehem, Pennsylvania plant alone employed 31,523 workers in 1944, more than double the peacetime level. The workforce included groups that had previously been excluded from heavy industrial employment. Tens of thousands of women, immigrant workers recruited from Mexico, and Puerto Rican workers who found employment in the hottest and most dangerous parts of the plant. During the war years, Bethlehem Steel alone produced more steel than the entire output of England. Pennsylvania led the world in steel production, with the Pittsburgh area producing 27% of the nation's supply. 41% of American steel came from facilities within a half-hour train ride of each other. The concentration of industrial capability in the mid-Atlantic region had no parallel anywhere in the world. 70% of airplane cylinder forgings for the U.S. Armed forces came from Bethlehem Steel. 1/4 of the armor plate for warships. 1/3 of the big cannon forgings. The experience of wartime mobilization left lasting marks on corporate culture. The assumption that the company could accomplish anything, if properly motivated, became embedded in management thinking. The success in meeting impossible demands through round-the-clock operations and aggressive problem-solving created confidence that bordered on hubris. If Bethlehem could arm the Allies for total war, what challenge could peacetime markets possibly present? This confidence would prove both a strength and a weakness in the decades ahead. Lance Metz, a historian who would later specialize in Bethlehem's history, summarized the company's importance. Bethlehem Steel was the most important to America's national defense of any company in the past century. We wouldn't have won World War I and World War II without it. By the late 1950s, the company was capable of producing 23 million tons of steel annually. In 1957, Bethlehem manufactured more than 19 million tons and earned $190 million on sales of $2.6 billion. These were the peak years, though nobody recognized them as such at the time. Arthur Homer, who had succeeded Grace as chairman, was the highest-paid corporate executive in America in 1958. But the foundations of decline were already being laid. The aging workforce was approaching retirement, creating pension obligations that had not been adequately funded. The technologies that had served so well were becoming obsolete, and the labor agreements that had maintained peace during wartime were establishing cost structures that would prove unsustainable against foreign competition. Basic oxygen furnaces, which used pure oxygen rather than air to convert pig iron to steel, were cheaper to install and more efficient to operate than the open hearth furnaces that dominated American production. Installation costs ran approximately $70 per ton of capacity, compared to $35 for open hearth facilities. Operating costs were lower because processing times were shorter. The quality was more consistent because the process allowed tighter control over chemical composition. Every metric that mattered favored the newer technology. Japanese and German steel industries, rebuilding from wartime destruction, adopted basic oxygen technology from the start. Their new plants incorporated the latest advances, unburdened by decades of accumulated infrastructure designed for older processes. When these rebuilt industries began exporting steel to American markets, they arrived with cost structures that domestic producers could not match. The competitive gap was not merely a matter of wage differences. It reflected fundamental choices about technology that American companies had made or failed to make during the prosperous post-war decades. The resistance to change within Bethlehem had multiple sources. Financial analysis that focused on short-term returns discouraged investments with long payback periods. Executives who had spent careers operating open-hearth furnaces were comfortable with familiar technology and skeptical of alternatives that would require new knowledge. The existing equipment still worked, still produced steel that customers would buy, still generated profits. Why spend billions to replace machinery that was performing adequately? This logic, reasonable in isolation, proved catastrophic when aggregated across the industry over decades. Bethlehem invested approximately $40 billion in open-hearth technology during the 1950s, despite evidence that basic oxygen furnaces offered superior economics. The company did not adopt basic oxygen technology until 1964 at facilities like Sparrows Point and Lackawanna. Even then, the transition was incomplete. By 1970, only 48.1% of Bethlehem's capacity utilized the more efficient process. Foreign competitors who had integrated the technology earlier and more extensively operated with significant cost advantages. The corporate culture that had served Bethlehem during its rise became an obstacle during this critical transition. Eugene Grace, who dominated the company until his retirement in 1957, fostered an autocratic environment that discouraged dissent and resisted change. Executives spoke of doing things the Bethlehem way, a phrase that captured both institutional pride and dangerous inflexibility. An internal efficiency expert in the 1960s attributed the company's emerging problems more to mismanagement and waste than to foreign imports. Research and development spending remained below 0.6% of net sales from 1975 to 1980, starving the company of innovations that might have restored competitiveness. The warning signs emerged clearly in the summer of 1959. Contract negotiations between the major steel companies and the United Steelworkers broke down over a management demand to eliminate Section 2B, a clause that limited the ability to change work rules, reduce crew sizes, or introduce automation. The companies argued this was a reasonable request. The accumulated inefficiencies of 2 decades of labor peace had created overstaffed operations that could not compete with leaner foreign producers. The union refused. Section 2B represented job security, the protection against arbitrary management decisions that had motivated workers to organize in the first place. Surrendering the clause would give companies unlimited power to eliminate positions, speed up work, and replace human labor with machines. The membership was prepared to strike to preserve it. On July 15, 1959, approximately 500,000 steelworkers across the country walked off the job. The strike shut down more than 85% of American steel production. In terms of person-hours lost, it was and would remain the largest work stoppage in American labor history. Steel inventories that customers had accumulated in anticipation of the walkout began to run short. Automobile manufacturers, appliance producers, and construction companies faced the prospect of shutting down their own operations for lack of raw material. The strike dragged on through the summer and into fall. President Eisenhower initially declined to intervene, believing that market pressure would eventually force a settlement. As weeks turned into months, that belief proved unfounded. On October 9th, Eisenhower invoked the Taft-Hartley Act. The Supreme Court upheld the injunction 8-1 on November 7th. Workers returned after 116 days. The final contract preserved Section 2B and provided minimal wage increases. In narrow terms, the union had won, but the real damage had already been done. For nearly 4 months, American steel production had essentially ceased. Manufacturers had been forced to find alternative sources. Ships lined up outside Philadelphia and other ports carrying imports from Japan, South Korea, and Western Europe. These customers discovered something that American steelmakers had not wanted them to know. Foreign steel was often of higher quality than domestic production, and it was cheaper even after accounting for shipping costs. Steel imports exceeded 5 million tons in 1959, the highest level to that point, and more than double the previous year. That number would double again within 6 years. The customers who had turned to foreign suppliers during the strike did not all return when production resumed. Some found that imported steel better served their needs. Others reduced their reliance on domestic suppliers to hedge against future disruptions. The import penetration that began during the 1959 strike never reversed. The basic economics of the situation had shifted against American steelmakers in ways that the strike made visible but did not cause. Japanese and European mills, rebuilt after wartime destruction with modern technology, operated at lower costs than aging American facilities burdened with outdated equipment and expensive labor contracts. The advantages of proximity to customers diminished as shipping costs fell and quality concerns evaporated. Foreign producers could deliver steel to American ports at prices that domestic mills could not match. The 1960s brought continued expansion of capacity, even as competitive pressure intensified. Bethlehem built its largest facility, the Burns Harbor plant on Lake Michigan in Indiana, between 1962 and 1964. Burns Harbor incorporated basic oxygen technology and represented a massive investment in modern capacity. But even this state-of-the-art facility could not reverse the broader trends. In 1967, Bethlehem lost its bid to supply steel for the original World Trade Center in New York. The contracts, including one for 50,000 tons of structural steel, went to competitors in Seattle, St. Louis, and elsewhere. The company that had built most of Manhattan's skyline could not secure the most prominent construction project of the decade. The 1970s accelerated the deterioration. Foreign imports reached 17% of domestic consumption by 1968 and continued to grow. Mini-mills emerged as domestic competitors, using electric arc furnaces to melt scrap steel at costs that integrated mills could not match. By 1978, hourly employment costs in the American steel industry reached $14.73 compared to $10.42 in Japan. Environmental regulations imposed additional burdens. The Clean Air Act required pollution controls that diverted capital from core operations. Steel mills that had spent decades externalizing environmental costs onto surrounding communities now faced demands to internalize them. The Occupational Safety and Health Act of 1970 mandated workplace safety improvements. These requirements served legitimate public interests, but they fell most heavily on industries that had historically operated with minimal concern for environmental or worker health impacts. The pension time bomb that Eugene Grace had armed during the prosperous 1950s began to detonate. The ratio of retirees to active workers climbed as the workforce that had built ships during the war reached retirement age. Pension obligations that had seemed manageable when the workforce was young and the company was growing became crushing when employment declined and the retiree population expanded. The funds that should have been set aside had not been accumulated. The gap between promises and resources grew wider with each passing year. Every worker who retired added to the liability. Every worker who was laid off reduced the revenue base that might have supported those liabilities. The mathematics were inexorable. The crisis arrived with devastating force in 1982. Bethlehem Steel reported an unexpected loss of $1.5 billion, the largest annual deficit in American corporate history to that point. The announcement shocked Wall Street, devastated communities across the Rust Belt, and forced the company into a defensive posture from which it would never recover. Analysts who examined the numbers found that the loss reflected not merely a bad year, but structural deterioration that had been masked during better times. Pension obligations had grown to levels that the company could not support with current revenues. Asset values on the books bore little relationship to what those assets could actually produce. The competitive position that had seemed strong just a few years earlier had eroded to the point where recovery appeared uncertain. Some wondered whether recovery was even possible. The response was contraction on a scale that transformed the Lehigh Valley and communities across the Rust Belt. Management identified facilities to close, operations to consolidate, and costs to eliminate. Each decision brought layoffs measured in thousands, then tens of thousands. Families that had worked at the steel for generations found themselves unemployed, their skills obsolete, their expectations shattered. The social fabric of steel towns began to unravel. Property values declined as workers left to seek employment elsewhere. Tax revenues fell, forcing cuts to municipal services. Schools that had educated steelworkers' children saw enrollment drop. Churches watched congregations shrink. The networks of mutual support that had sustained working-class communities depended on the economic foundations that steel employment provided. When those foundations crumbled, the structures built upon them began to collapse. The unions faced impossible choices: accept concessions their members had fought decades to achieve, or resist and watch jobs disappear entirely. Neither option offered good outcomes for the workers they represented. The negotiating power that unions had wielded during periods of labor scarcity evaporated when unemployment lines stretched around the block. Plant closures cascaded through the network of facilities Bethlehem had accumulated over decades of expansion. Each closure was announced with corporate language about difficult decisions and changing market conditions, but for the workers and families affected, the language meant the end of a way of life. The Johnstown plants, originally founded by the Cambria Iron Company in 1852 and acquired by Bethlehem in 1923, closed in 1992. Generations of families had worked in those mills, fathers teaching sons the craft of steelmaking, the knowledge passed down like an inheritance. Now that inheritance was worthless. Coal mining ceased in 1991. The railroad car business was sold in 1993. Shipbuilding ended in 1997. November 18, 1995. The blast furnaces at the Bethlehem plant produced their final heat of iron. Workers who had spent careers in those mills watched as molten metal flowed for the last time. Some wept openly. Others stood in silence, unable to find words for what they were witnessing. 140 years of continuous steelmaking in Bethlehem had come to an end. The executives spoke of dignity and pride, but for the workers and their families, the emotions were more complicated. Grief mixed with anger, nostalgia tinged with bitterness. They had given their bodies to this work, breathed its fumes, endured its heat, risked their lives in its service. And now it was over, not with celebration, but with closure notices and severance packages and the promise of retraining for jobs that might never materialize. The company struggled on through the late 1990s, shedding assets and searching for a sustainable business model in an industry that seemed determined to eliminate domestic producers. Foreign competition continued to intensify. The Asian financial crisis of 1997-98 flooded world markets with cheap steel as distressed producers dumped inventory at any price to generate cash. Mini-mills captured an increasing share of the domestic market. Each restructuring seemed only to delay the inevitable rather than chart a path toward recovery. On October 15, 2001, Bethlehem Steel Corporation filed for Chapter 11 bankruptcy protection, the 25th American steelmaker in 4 years, to seek similar relief. The filing cited losses of nearly $1.5 billion in the first 9 months of 2001 alone. Foreign competition, legacy costs, and the lingering effects of decades of underinvestment had finally overwhelmed the enterprise. The pension obligations proved catastrophic. The fund was underfunded by approximately $4.3 billion. The Pension Benefit Guaranty Corporation assumed responsibility for payments, the largest pension assumption in PBGC history. But PBGC coverage had limits that many retirees discovered only when their benefits were cut. Workers who had been promised pensions of $30,000 per year found themselves receiving less than $18,000. The PBGC capped benefits based on the age at which workers retired, and those who had taken early retirement during the long years of layoffs faced the steepest reductions. Russell Sexton of Valparaiso, Indiana, who had worked at Burns Harbor for more than 31 years, saw his pension cut from approximately $30,100 to about $17,700. "I'll probably lose my home," he told reporters. "I just went from a middle-level income to poverty level." The health insurance situation was worse. The PBGC does not cover retiree medical benefits. More than 95,000 retired steelworkers and their dependents lost their company-provided health coverage entirely. The value of those lost benefits was estimated at $3.1 billion, money that the PBGC did not pay and that retirees would have to find elsewhere or simply do without. Steve Miller, the restructuring specialist brought in to manage Bethlehem's final years, captured the situation with brutal clarity. "We do not have the money to make good on all the promises made by this corporation over the last 50 years. In February 2003, International Steel Group purchased Bethlehem's remaining assets, including 6 operating plants, for approximately $1.5 billion. The transaction was structured to shed pension and healthcare liabilities, allowing ISG to acquire productive capacity without the obligations that had dragged Bethlehem into bankruptcy. The union signed a new labor agreement that ISG described as innovative, though critics noted that it eliminated many of the protections previous generations had won through struggle and sacrifice. 2 years later, ISG merged with Mittal Steel, ending American ownership of the assets that had once been central to the nation's industrial identity. The company that had built the Golden Gate Bridge, armed 2 world wars, and shaped the Manhattan skyline had been absorbed into a multinational corporation headquartered in Luxembourg. The Bethlehem name disappeared from the industry entirely. The physical legacy endures in forms both magnificent and melancholy. The Golden Gate Bridge still carries traffic between San Francisco and Marin County, its towers rising 746 feet above the water, still painted in international orange. The span has carried more than 2 billion vehicles since 1937. Engineers have reinforced and retrofitted the structure to meet modern seismic standards, but the basic skeleton that Bethlehem fabricated remains in place. Joseph Strauss, the chief engineer, received most of the public credit, though the engineering work was actually led by others, including Charles Ellis. What matters for the story of Bethlehem Steel is simpler. The company that had started as a small iron works in the Lehigh Valley had produced the material for one of the most recognizable structures ever built by human hands. The skyscrapers of Manhattan continue to define one of the world's most recognizable skylines. The Empire State Building still rises 102 stories above Midtown. Rockefeller Center still anchors the business district that grew up around it. The Chrysler Building's Art Deco spire still catches the light at sunset in ways that photographers travel from around the world to capture. Bethlehem beams still support these structures, hidden behind facades and interior finishes, but still performing the work they were designed to do nearly a century ago. At the original site in South Bethlehem, 5 rusting blast furnaces still stand, rising approximately 285 feet above the Lehigh River, monuments to an industrial age that has passed. Rather than demolishing these structures, the city chose preservation. The decision was controversial. Some argued that the furnaces were eyesores, reminders of pollution and industrial blight that the community should move beyond. Others saw value in maintaining a physical connection to the past, in preserving structures that told a story about American industrial achievement and its costs. The preservationists won. The site has been transformed into steel stacks, an arts and entertainment district hosting concerts, festivals, and community events in the shadow of the idle furnaces. The Arts Quest Center, a 67,000-square-foot cultural facility, opened in May 2011. The Levitt Pavilion provides a venue for free concerts with lawn seating for 2,500. Music Fest, one of the largest free music festivals in America, takes place annually on the site, drawing crowds who dance where molten iron once flowed. More than 1 million visitors come each year, making it one of the most successful brownfield redevelopment projects in the country. The Hoover Mason Trestle, which once carried raw materials to the blast furnaces, has become a pedestrian walkway. Visitors can walk along the elevated path, reading informative plaques about the industrial processes that once occurred beneath them. Photographers come at sunset to capture the rust-colored patina of the furnaces against the sky. Artists paint the structures in oils and watercolors, finding beauty in the decay of industrial monuments. A casino opened nearby in 2009, funded by the Las Vegas Sands Corporation and later sold to Wind Creek Hospitality. The irony difficult to escape. A company town built on production now sustains itself partly on gambling, an industry that creates nothing tangible. The casino generates tax revenue and provides employment, but the jobs pay less than steelworker positions and offer fewer protections. The transformation from manufacturing to services that characterize the American economy writ large played out in microcosm along the Lehigh River. The National Museum of Industrial History operates on the former Bethlehem Steel site, affiliated with the Smithsonian Institution. Visitors can learn about the company's role in building American infrastructure, examine artifacts from the manufacturing process, and watch documentary films about the workers who spent their careers in the mills. The museum tells the story of triumph and tragedy, of an enterprise that rose from modest origins to become essential to national defense and then collapsed under pressures that no amount of heroic effort could overcome. Martin Tower, the 21-story corporate headquarters built in 1972, stood for decades as a symbol of both ambition and miscalculation. designed as a monument to permanence at a moment when the foundations of that permanence were already crumbling. Within 15 years of its construction, the tower was nearly empty, its offices abandoned as layoffs eliminated the white-collar workforce along with the blue-collar workers in the mills. In May 2019, the tallest building in the Lehigh Valley was demolished in a controlled implosion witnessed by thousands of former steelworkers and their families. Somewhere in that building, in an office, is where everything went wrong, a longtime resident had observed. More than a quarter of families in South Bethlehem now live in poverty. 90% of children in local public schools qualify for free or reduced-price lunch. The casino was supposed to transform quality of life for residents of the former steel town. Some benefits have materialized, but the distribution has been uneven. Former steelworkers and their families ask where the transformation in their quality of life has occurred, why so many children still live in poverty, why the prosperity promised by redevelopment has not reached the neighborhoods that bore the heaviest costs of deindustrialization. The questions that Bethlehem Steel's history raises remain contested and probably unanswerable with certainty. Was the company's collapse inevitable given structural forces reshaping the global economy? Or did specific decisions by specific people at specific times make the difference between survival and failure? The academic literature on Bethlehem Steel's decline offers multiple explanations that are not mutually exclusive. Economists emphasize competitive dynamics, the entry of low-cost foreign producers, the emergence of mini-mills that could produce steel more cheaply for certain applications, the decline in demand for heavy structural products as construction methods evolved. Business historians focus on managerial failures, resistance to technological change, short-term orientation that sacrificed long-term positioning for immediate profits, governance structures that insulated executives from accountability. Sociologists and labor historians note class dynamics separating management from workers, racial and ethnic hierarchies within the workforce, the gendered assumptions that excluded women from most positions until wartime labor shortages forced accommodation. Political scientists examine policy failures, trade policies permitting imports without adequate protection for domestic producers, environmental regulations imposed without transition assistance, pension rules allowing companies to underfund obligations that workers would depend upon in retirement. Each explanation captures part of the truth. The full story encompasses all of them and more: the contingencies of history, the personalities of individuals, the choices that seemed reasonable at the time but proved mistaken in retrospect. Understanding what happened to Bethlehem Steel requires holding multiple explanations simultaneously, recognizing that complex outcomes have complex causes that cannot be reduced to single factors or simple morality tales. The American steel industry faced structural challenges no single company could have overcome entirely. Foreign competitors enjoyed advantages in labor costs, technology, and capital investment that domestic producers could not easily match. The decline of Bethlehem Steel was part of a broader transformation of the American economy from manufacturing to services, from production to consumption, from making things to managing information. These forces operated beyond the control of any corporate board. But decisions mattered too. The choice to invest in obsolete open-hearth technology rather than basic oxygen furnaces during the 1950s left Bethlehem operating with outdated equipment when competition intensified. The failure to fund pension obligations adequately created liabilities that became unmanageable when revenues declined. The confrontational labor relations that characterized management under Eugene Grace prevented the cooperation that might have eased necessary transitions. The insular corporate culture that rewarded doing things the Bethlehem way discouraged the innovation that survival required. What can be said with confidence is that Bethlehem Steel mattered. The company built the physical infrastructure of American power during the century when the United States became the dominant nation on Earth. Its blast furnaces supplied the metal for bridges that connected communities, buildings that housed commerce and culture, weapons that defended democracy against totalitarian aggression. The workers who labored in those mills, often in conditions of extreme heat and genuine danger, created tangible value that endures in steel and concrete across the landscape. The collapse of the company destroyed that value for many of the people who had helped create it. Pensions evaporated. Health insurance disappeared. Communities fell into poverty from which they have not recovered. The cost of Bethlehem Steel's failure was paid most heavily by those who could least afford it, the workers and retirees who had trusted promises that the company could not keep. 7 furnaces once operated simultaneously along the Lehigh River. Only 5 remain standing. The oldest dates to 1915. The distance from the westernmost furnace to the easternmost spans approximately 1,100 feet, nearly a quarter-mile of industrial history frozen in rust. It took 3,366 pounds of ore, 1,676 pounds of coke, and 724 pounds of limestone to produce 1 ton of iron in those furnaces. The mathematics of steelmaking was precise, unforgiving, and ultimately subordinate to the mathematics of global capitalism. When the numbers stopped working, the furnaces fell silent. The men and women who had fed them found themselves citizens of a changed country in which their skills and their sacrifices counted for less than they once had. The steel that Bethlehem forged is still doing its work, supporting structures that millions of people use every day without knowing or caring where the material came from. The company is gone, but the things it built remain. That is a kind of immortality, even if it is not the kind that the men who ran the company or the workers who labored in its mills imagined for themselves. 68,000 tons of Bethlehem steel still hold up the Golden Gate Bridge. The company that forged them exists only in memory. The judgment of that transaction belongs to history.